All right, I think we can get started now. All right, hello DrupalCon. My name is Eric Napier. I'm here with Gerardo Gonzalez. We're from Civic Actions. We're excited to present today what we've learned working with TDD. Our contact info is on this slide. I'll show it again at the end. Check us out on GitHub. Civic Actions manages the DCAN project, which is an open source, open data platform. And here's a link to the slide deck I'm using today. Thanks everyone for joining us. We're here to talk about unit tests and test-driven development. We're going to talk about the history of TDD a bit, where the practice comes from, how it works, how to do it in Drupal, and how we've come to adopt it in our own work. We'll give you some tips for writing unit tests. There's going to be lots of code demos, and we got a lot to cover. So let's jump in. We're talking today about test-driven development. The concept comes from a book called Test-Driven Development by Example, written by Kent Beck in 2003. It's the same Kent Beck that wrote Extreme Programming just a few years before that and had time to create the Agile Manifesto somewhere in between. TDD is all about test-first programming, but Kent didn't invent this idea. The idea of test-first goes back as early as NASA's Project Mercury. And you can read about all this stuff on nasa.gov. It's actually truly fascinating, the scope of this project. NASA needed software developed for manned mission control computers. And IBM, the contractor, in their proposal stated that modularization and unit testing would be the norm. The overall system was broken into several large testable components. And the tests defining the expectations for each subsystem were developed before the systems themselves. So the units were much larger than what we think of as units in TDD, but they were doing test-first programming. Though back then, developers never wrote their own tests. Instead, there were dedicated teams of testers, and it was believed programmers really shouldn't write their own tests. And this is something Kent Beck really tried to change when he started writing about TDD years later. All the tests were manual. This started to change in the 70s. The first book on software testing was published, and automation became a huge concern for everybody. New tools in the 70s made automated testing easier than ever before, like NASA's automated test data generator, the very first data generation tool for testing. By the 80s, test automation was mainstream. The first tool for automated testing on the PC was released in '85 and generally became best practice to automate at least some degree of testing for big projects. So QA teams got some relief. We also see the rise of rapid prototyping in the late 80s and the use of time-boxed iterations, something important to Agile later on. These trends continued into the 90s. Rapid prototyping continued to be a hot topic, and in '96, Kent Beck began using some new methods in his work as project lead for Chrysler that he eventually called extreme programming. So we see best practice up to this point has trended towards test-first programming, automation, smaller iterative cycles. Extreme programming takes all these practices to the extreme level, creating more feedback loops at different increments of time. So instead of the dedicated teams of testers, programmers are writing their own tests and then running them continuously as they write and refactor code. So feedback can be received in just a matter of seconds. All these processes that are part of extreme programming are meant to provide better feedback, but today we really want to focus on the one that perhaps provides the quickest feedback, and that's TDD, test-driven development. And it was really formalized in the book Test-Driven Development by Example from Kent Beck. There's a quote that I really love from this book. If you don't drive development with tests, what do you drive it with? Speculation? Specifications? It's true, if we're not driving our development with tests, we must be driving it with something. My first experience working on the web is very much a spec-driven process. Lots of specification up front and lots of speculation. This was 2005. We would spend months planning a project, writing specs, creating designs we hoped could be implemented on the web. And after many rounds of back and forth with the client, we'd finally get approval, a deadline would be set, and then the project would go to development. From there, programmers would have these specifications to reference and the speculation would begin. So what I'm describing is a waterfall process, and generally recognized as outdated today for web development. As you can see from the diagram, testing is something that comes at the very end of the process. At that point, it's really too late to get the kind of feedback you need to make big changes. But this was the workflow I was introduced to back in 2005. I worked for a print publishing company where this was the model, and for many businesses pushing to build an online market in the 2000s, this waterfall method made a lot of sense to them. But it wasn't really in sync with the lessons learned in the world of software at the time. So we were doing a ton of outdated stuff back in 2005. We were building custom CMS products in PHP using LampStack, CVS version control. Publishing was simply running CVS update and prod. There were no server automation tools that we used at the time, no continuous integration, no automated tests. So there was no code coverage after the code was written, and nothing sort of running as we checked code in to give us feedback. Cycles were really long, months to maybe a year before we would get feedback. And a major refactor after a year can be really expensive. As a result of all this, projects were often delivered late. Releases were unpredictable. We'd wait till Friday nights to do deployments and spend the weekends debugging things. Overall, this was a hugely stressful way to work, and knowing what I know now, it would have been nice to have some tests in place to give us confidence. I learned a lot from these experiences, though. We need to have confidence in our programs as we're writing them, because confidence equals less stress, and less stress equals cleaner code. The opposite of confidence is fear. We don't do great work when we're afraid. We do our best work when we're relaxed and getting continuous feedback that we're on the right track. Today, I work for Civic Actions. We're a company focused on government, nonprofit services. We've been working with Drupal since version 4 in 2005. We're specialists in Agile training and providing Agile services. We still work with agencies today, though, that are anxious to transition from the old waterfall model, and it's exciting for us to bring them into the world of Agile. Agile kind of counters all the pain points of waterfall. With Agile, it's all about fast, continuous feedback, pair programming, unit testing, real-time feedback. We have CI pipelines running automated tests on all our code before it gets checked in. We have much shorter development cycles, and we focus on small deliverables for each of those cycles. But the important thing is at every step, even every line of code, there's built in the opportunity for feedback. And this is in sharp contrast to the waterfall method. Instead of requirements and analysis and design all up front, it's woven into the process a piece at a time. Instead of code delivered all at once before any testing, the full product is delivered in small increments with testing woven into the process. And what we practice as Agile today really grew from that smaller community of extreme programmers. Fowler and Beck, all their friends, and TDD was a central practice for them. Automated testing much more frequently, shorter cycles, faster everything. So at Civic Actions, we were anxious to experiment with TDD, and we wondered how far can we take it in Drupal? So that's what we're talking about today. At its core, TDD is a very simple process. Write a test first, see the test fail, write just enough code to make the test pass, and then let the test drive your workflow. Kent Beck's book outlines a method for taking the fear out of development and replacing it with simple designs and clean code that works, using very small steps and a test-first mindset. So with TDD, there's just two rules. Write new code only if an automated test has failed, and eliminate duplication. This implies an order to the tasks of programming, and TDD sums this up with this idea of red, green, and refactor. The red phase, you write a little test that doesn't work, perhaps doesn't even compile at first. In the green phase, you do whatever you need to do to get that test to pass, committing whatever sins necessary in the process. And then refactoring by eliminating all the duplication created just merely to get the test to work. An interesting rhythm comes from working like this. By creating the test first, you create a feedback loop that helps you write the code. TDD tries to create the smallest feedback loop possible. And the process of writing a test up front might feel a little unnatural at first. And you may be wondering, how can I test something when I don't know how it's going to work? but it's fairly simple to get started. So now I'd like to introduce you to Gerardo Gonzalez. Gerardo is an open data engineer at Civic Actions, and he's going to give us a quick demonstration of writing code using the technique of red, green, and refactor.
Cool. So if I'm sharing my screen at the moment, so if you want to see it larger, double click on it so you can see what's happening in my screen. All right. So for all of the tests that we're going to be demoing today, we're going to be using PHP Unit. So if you've never used PHP Unit before, the basics are all of your tests are in classes, and they have to extend this PHP Unit framework test case class that is provided by PHP Unit. The other thing that's important is, so all of these classes that are extending this class will be recognized as a PHP Unit test, and then inside of your class, you will have multiple methods, and each of those will be treated as a test by PHP Unit. So where do we start? When you're going to start your red-green refactor cycle, the first thing that you need is something to implement. So in this case, we want to start with a simple example. We want to create a simple in Memorystore. We want to be able to save some strings and then be able to retrieve them later on. And that is it. So where do we start? Well, let's write the code that we think will suffice these requirements that we just talked about. So we mentioned that we want to have a store. So we have a store object. Let's call it simple in Memorystore. And we want the store to be able to store things. In this case, we want to store strings. Let's go with the classic hello world. And when we store a string, we expect this store object to give us back some sort of identifier, so we can retrieve our store string later on. So we get an identifier. So that's our first requirement. But we also know that we need to be able to retrieve the strings. So this is the second part. So our store should also have a retrieve method. And when I give that method the identifier that I know about, it should give me back my string. So this code should run once we have an actual implementation of things happening. But we're missing one last thing that all tests should have, and that is assertions. So we want to check to make sure that our implementation is to do. In this case, our expectation or the assertion that we want to do, that we want to check for, is that whatever we retrieved is equal to the thing that we initially gave in. So our expectation is that we will get back hello world, and that is what the store gave us, which was stored in the string variable. Okay, so now we have a full test. Let's run it. Now this command is going to look weird. This is the only reason why I have this magical looking incantation here is because I'm running everything in Docker, and so I have a Robo. If you're not familiar with Robo, that's what Drupal 9 and above use as a framework to build its CLI tool, and we're using this in some Dockerized environment. And so this is just that Robo command that runs PHP Unit inside of the container. So this is just PHP Unit inside of the container effectively.
Hey, Gerardo, if you can bump your font size, been a few requests for that.
Oh, yes, I can do it here. Does that look better? Hopefully it does.
Better, yeah.
Okay, so here, so now we get our first part of the cycle. We get red. Obviously, we get red because simple in Memorystore does not exist. We're trying to utilize a class that has not been implemented. So now we're trying to get to the second part of the cycle, which is we want to go from red to green. We want to implement this as quickly as possible to get to green in our tests. So in Drupal, we want to put all our classes inside of a source directory inside of our modules. In this case, I have this custom module here. And then inside of here, I'm going to create my class. And we know our class is called simple Memorystore. Let's go ahead and use the Drupal namespace. All the namespaces for your classes in Drupal are going to be Drupal, the name of your file, of your module, and that will allow the Drupal Autoloader to load our class for us. Okay, so here's our class, and we know that our class needs to have two methods in accordance to our test. It needs to have a store method, and this method is a string, or it gets a string, and it should return an identifier. So here's where we commit our first sin. We're just hard coding some sort of value being returned by our class. We also need a second method called retrieve. And this one should take an identifier, and it should return a string. And here's the second sin that we will be committing today. And that's that we're going to return string directly. So we know that our tests should pass at this point because we're hard coding things to meet the expectations of the test. So let's run our test again, see if we got to green. Oh, we didn't. Simple in Memorystore. Did I name things incorrectly? Simple in Memorystore. Simple in Memorystore. Here's where demos come to bite you in the butt.
I saw a couple comments. Is capital, double exclamation.
Well, but the class is not even recognized. So the autoloader is not.
Test needs a new.
Oh, yes. Thank you so much.
For the win.
But over here is still acting like it doesn't know what this class is. Simple in Memorystore. My namespace is correct, I think. Feature article.
Use function should just be use function.
Well, I'm so glad I have you all to help me figure out what the heck I'm doing.
It's pair programming. Yes.
Yay! So now our class is being recognized, but as you all notice, we didn't get to green because the expectation, the sin that I committed is not even sinful enough. We need to return the correct string. Hooray! Thank you so much for all your help. So now we're to green. The next step is we want to go from green and stay green, but now we want to remove duplication. This whole duplication concept is just some sort of weird concept that Kenbeck presents in the book. I like the refactor terminology better. So we want to refactor our code to be the actual implementation. But what does refactor mean in our context? The most important thing for you to consider new code a refactoring instead of like a new feature or some sort of rabbit hole that you want to go down to is that your initial test, the essence of it should stay pristine. So we don't want to implement new parts of a test. We want to just make this test continue to pass. Sometimes you do have to modify your test slightly, so don't feel like this is a handcuff. What's important is that we're testing two important APIs here. We want to be able to store things, and we want to be able to retrieve things. And as long as we keep those pristine, then this will be considered a refactor instead of adding a new feature or some other kind of new code addition or a bug fix or whatever other things you can do with the code base. In our case, we don't have to modify the test because it's simple enough. So let's go ahead and write the implementation really quickly, and hopefully this time I won't make any mistakes. So we want to store our stuff in a simple array. And then we'll just store the things sequentially in that array. And since we're storing things sequentially, we know that, and if we want to use the key in the array as the identifier, we know that we can just get the size of the array -1 because we start counting from 0, and that will be our identifier. And this will help us to simply be able to retrieve that element from the array and return it. All right, so now let's run our test again to see if they still pass with our actual implementation. Hooray, so we're still green and we have actual working code. So now you might wonder, so what do I do next? Where do I go next with TDD? Well, you can have infinite number of cycles. What might you do in a new cycle? For example, here, we're doing something bad, which is we're not checking that our identifier actually exists in the array. This can cause some issues. So you might create a test that checks for a failure here, and then you write a correct implementation on top of that. Or you might have new features that you need to implement, like being able to remove the strings from the store. Those are all things that you can do in a new cycle. And what I like to do is when those things come into my brain, I just like to write comments here so that I can remember to come back to them later, like remove strings from store. That way I don't follow the rabbit holes, but I'm not losing track of the things that I need to implement on further cycles. All right, let's go back to the content.
Thanks, Gerardo, and thanks, everyone. So as we can see from looking at this demo of red-green refactor, in order for the rhythm of TDD to work and for writing tests alongside code to not feel like a huge burden, it's important for the tests to run super fast. So let's talk about how to write super awesome, super fast unit tests. The feedback received from a unit test is only useful if we receive it very quickly after requesting it, else we spend too much time waiting for test results. We lose the rhythm of red-green refactor. So to run as fast as possible, unit tests use test doubles as stand-ins for real system objects and behaviors. The central component for any unit test is referred to as the system under test, or SUT for short. All other classes or objects that this SUT needs to run are referred to as dependent on components, or DOC. So when a SUT has too many DOCs, or the implementation of a particular dependency is resource intensive, it's possible the test can become too slow to run. And TDD programmers often want to isolate the system under test better by faking the implementation of dependent classes. And this is what test doubles allow us to do. It's possible to replace all dependencies with a test double. Or a unit test could contain a mix of test doubles and real objects. There's always a trade-off between speed and the level of feedback that you need from the test when choosing if to use a test double. One way to think about this difference is with the terms solitary and sociable. These terms are referenced frequently by Martin Fowler, but first introduced by Jay Fields in a book called Working Effectively with Unit Tests. A sociable test is one that doesn't use a testable. It uses real-world implementations for everything. This was the approach of the early extreme programmers like Fowler and Beck, and it's called the classic TDD approach often. One advantage is that any problems that might occur in the real world by integrating components can be caught right away before running acceptance tests later. So this approach is great when designing a brand new system. The tests act as sort of a filter to remove excess complexity. It's in order to keep the tests running fast, you have to avoid coupling between components and creating these big dependent classes. A solitary test is one that creates doubles for all dependencies, so the system under test is the only thing that's fully implemented. This approach has different advantages. Tests should always run super fast, even in a system with many large core dependencies. And unit test failures for one component should not cause other tests to fail. You see this approach a lot with unit tests in Drupal 8 and 9, usually through the use of mocks. And it makes sense. In large complex systems like Drupal, there are many interconnected components. As you can see from this visualization of the database, there's a lot of interdependent components. Inevitably, you want to isolate some of this when creating new unit tests for a module. At Civic Actions, we often use a mix of these approaches in a single test. So, and you'll see this in core a bit as well. Our motto is whatever works to provide the fastest test with the type of feedback that you need. Some tests may need more or less isolation. So let's look at some of the techniques for creating test doubles to isolate components. This is a list of several different types of test doubles used in TDD. Names like dummies, stubs, mocks, spies. There's a few others. Each have a unique usage and differ in the complexity they offer in copying the original object. The terminology in PHP unit for these is simplified a bit because all test doubles are created as instances of PHP unit's mock object. More on that in a minute. In TDD, these different types of test doubles give you different options in your tests. For instance, if you want to test behavior and not expectations, or vice versa. As you move from the concept of dummy to mock, your options increase. The dummy tests nothing. It's just there to meet some dependency the test doesn't care about. You might see this a lot in Drupal. The mock actually tests behaviors as well as expectations and even registers method calls. You can do everything here in this table using PHP unit's get mock builder method with the different combinations of calls to its internal methods. And there are also two methods called create mock and create stub that are available, but these actually just provide default configurations, default calls to the get mock builder method. So we're just going to be focusing on get mock builder in our demo today. This is the full list of methods that can be called on get mock builder. Like I said, different combinations of calls to this method can be used to create all the test doubles used in TDD. The method's kind of poorly named. It would map easier to TDD concepts if it was named something like get test double, but that's okay. We mainly want to discuss when to use social or solitary components, and we'll leave the rest of this for you to explore. There are a lot of roads on the road to TDD, and the more you know, the more powerful your test is going to be. Using PHP unit, there are actually several options for creating test doubles to make solitary tests. We've been talking about using PHP unit's internal mock object. Depending on what kinds of tests you're writing, you might find this object limiting, and there are actually other ways to hook up test doubles in a PHP unit test. It's possible to create them the old-fashioned way. Just create your own class and substitute for the real class. Then you can add as much or as little as you want. This may be useful if you want to mock like a private method in a class, for instance. The PHP mock object does not allow you to do this. Most mocking frameworks do not. PHP unit also includes a prophecy library, which is used by some modules in core. It provides a bit of a different workflow for creating test doubles. It's just a little bit different, and we've not really adopted it yet in our own workflow, but since it's built into PHP unit, you should really check it out. There's also some external libraries. Mockery is a really interesting one because it has an object naming scheme that maps really well to TDD. So if you're getting familiar with TDD concepts, this might be something cool to check out. And finally, we'd like to introduce you to the Mockchain library. This is something Gerardo created for DCAN and something we've been using to create shortcuts for PHP units mock objects in our tests. So over to you, Gerardo.
All right, I'll try to go quickly on this demo since we lost some time with the technical difficulties on the last one. So here we just want to demonstrate a little bit what solitary versus sociable means. So I created a new class called JSON store. And if we look at the implementation, and it's very similar to the simple in Memorystore. As you can see here from the test, the interface is very similar. We have a store method, we have a retrieve method. The only interesting thing about the JSON store class is demonstrated here in the second test. So here we're trying to feed it a string, but the string is bad JSON. It's not a proper JSON object because we're not closing the curly brace. And when we try to feed this into the store, it's gonna give us an exception. And so this is showing what the new functionality of the JSON store is. Some of you might be wondering if this JSON store has such similar interface compared to the simple in Memorystore, why doesn't it just extend it instead of passing the simple in Memorystore as a dependency? Well, even though parent and child relationships are some sort of form of connection that could be thought as a sociable kind of interaction, this is a more direct example. Like here we're demonstrating very directly that that JSON store depends on the simple in memory class. Okay, so our goal here is to demonstrate that we can mock some of these things and still get useful tests happening. So let's run the test first just to show you that they're working. So I'm running the JSON store test, and there are 2 of them, and they're green at the moment. So what we want to do now is replace this actual implementation of the simple in Memorystore with a mock, with a fake. In this this first example that I just show, this is a sociable test because we're using the actual class, the actual code from the simple in Memorystore is running. If in this case, this makes sense because it's a very simple object. But if we were dealing with something in Drupal, let's say something like the entity repository class, those are much more complex. And in some cases, we do not want that code to run because it might be trying to do too many things. And so we want to mock it. Okay, so what does a mock look like? As Eric mentioned, with PHP unit, we get this get mock builder out of the box. All you have to do is tell it which class you're trying to mock or create a double for. It has some configuration options like do not run the constructor. You can tell it which methods you want to override. And then finally, when you get your mock, then you can define your behavior. So in this case, we're saying when the store method is called, please return 0. And when the retrieve method is called, please return the proper string. So let's go ahead and replace our real implementation with the mock that we created. All right, so now we're passing the mock instead of the real implementation. We have one with the mock and one with the real implementation. Let's run the tests again. And they're still green. All right, so our mock is behaving as the real object will behave. So now I want to do a little plug for our library, the Mockchain. As you can see, it removes some of the verbosity on the mock creation. It makes some assumptions for you, and it also allows you to give way more information in a single line of code. So here we're saying, this is what we're mocking. We want to mock this method, and that's what we wanted to return in a single line. And then we can also give information about other methods that we want to mock after the initial after the initial one. So it saves you some verbosity. Here is not so obvious, but if you had a big chain of mocks like in Drupal, you might have like a node that returns a field item list, that returns a field item, that returns a value. Those can get very verbose and very complicated, and the Mockchain helps a little bit to reduce that amount of code. So let's go ahead and run the Mockchain mock. And let's see that the tests are still passing. And so in this case, this is an example of a solitary test because we're mocking the dependency and only the code that is unique to the JSON store is running as part of our test. So different options, different ways to do it, and mocking is the way that we can go from one stream to the other, how much mocking you do versus how little mocking you do. All right, back to you, Eric.
All right, so now we want to talk about how to do this all in Drupal. We've been using PHP unit in this demo. I think you had a question there, Gerardo, about running the test. But yeah, we're using PHP unit for all this. PHP unit's in core now as of Drupal 8 and continuing with Drupal 9. The major architecture changes to Drupal and Drupal 8 also really supports testable code, the object-oriented module structure, dependency injection, services, containers, all these things make for a structure that can be tested really well. The more that you keep out of your .module file, the more testable your modules will be. There's a few classes that extend PHP unit and core. Primarily, if you're doing TDD, you're going to want to use the unit test case class. This adds a few additional things to the regular PHP unit test case. It sets up a container with cache tags and validator, unsets the container between the tests in the setup method. It provides a few mocks, like for the config factory. There's a mock of the block entity and translation object. And this class also provides some methods for random generation. It's also super minimal, so it's reliably very fast. Just create your test as an extension of this class, and you'll be able to do most everything you need to do for TDD testing. There are a couple other classes that extend PHP unit, but these are more for integration testing. And so far, we've not extended these classes in our own TDD work. We have been experimenting a lot with Drupal test traits, and we wanted to shout out to this project. We saw their demo last night, and we've been using this tool for the last year doing integration tests. So for things that, you know, testing the acceptance of functionality after it's built rather than driving the functionality with tests is typically how we use that. But it's a really cool tool that gives you a bunch of new classes that extend PHP unit and allow you to do end-to-end tests in a bunch of really cool ways. So there's gonna be a lot of challenges you will hit if you want to do TDD in Drupal. First of all, lots of mocking will be needed. Some services are just used everywhere, and you're not going to want to fully implement them in all of your tests, like entity type manager, config manager. You'll constantly be asking yourself where you'll draw the lines for solitary and social components. We recommend, you know, anything that relies on the database or the file system should be mocked. Anything that's resource intensive should be mocked, and you'll be able to tell this by the speed that your tests run. You really want them to run super fast. So if they're not running fast, that might clue you in that you should mock something that your test is bringing in. Also, testing hook implementations. This is maybe perhaps a topic more for site builders than module builders, but I'm sure it comes up a bit. But the hook implementations, the internal logic for it can be covered with unit tests, and we're going to show you this in our demo in just a moment. But you're really going to want an integration test end-to-end to cover your code in a hook, just to make sure that the hook is triggered correctly and does what you intend it to do. Also, another big challenge of testing in Drupal, unit testing in Drupal, is just that it's Drupal. There's no shortcut to mastering Drupal. The more knowledge you have of that system, the better your tests are going to be. But the good news is unit test is actually a really great way to explore Drupal. Once you start digging in and mocking objects, you're going to find yourself down in core trying to figure out how those classes are made up. So you learn a lot by doing this process. And now we're going to show you how it works in Drupal.
How we can do this? We have about 5 minutes left, and okay. So up to this point, we've been doing a lot of just TDD on classes that we're creating, but nothing really Drupal-y. And so we wanted to tie it all down by showing a more Drupal-specific example. So in this case, this is the scenario. Let's say that you want to have some new functionality for the article content type on your site. You want to be able to feature some articles. And so you want to have a field possibly that is going to keep this information, whether the article is being featured or not. But where things are interesting for our use case is that you can only have one feature article in the site at any given time. And so to kind of mention again what Eric talked about, that there is no shortcut for knowing how Drupal works. Like, so all of those, all of you that have been around here and know some Drupal. When I describe what we were trying to accomplish, you probably immediately thought hook, entity hook, probably a Presave hook, because we know that when the notes are coming in, we can do some checks to see if the article is being featured. And if that is the case, then we can have some logic to remove any other feature articles from the site. So that's just something that you need to know. And with experience, you will know where your logic belongs in Drupal. And then you can do your unit tests, knowing that that's the environment in which your test is going to be running. So here I have my 3 comments that kind of describe what I just mentioned. We want to have some functionality that allows us to check if an article is featured. We want to have some functionality that allow us to retrieve previously featured articles so that we can then remove the flag from them and cause them to not be featured. So because we don't have a lot of time, we're only going to run through the TDD of this first scenario. So we already have the test here. I'm going to go ahead and run it. And I actually have some implementation already also. But hopefully this will still be useful for you to understand how we're doing TDD in Drupal. Okay, so our test did not pass because the implementation of this method that I'm calling is article feature expects a node. And as you notice from our code, we're just giving it a null value. So this is the first step. We are red. We want to try to get to green. So let's create a mock of a node object. So let's use the Mockchain since that's our preferred method at the moment. So I'm just gonna say that I wanna mock a node. I can get the mock. All right, and now I'm passing a node object into the function, which is what it expects. Let's run the test again. Okay, so now we're getting a new failure. So it's not failing because it was not a node. It's failing because it's getting to a point in which the Drupal container is expected to exist and our unit test is not bootstrapping Drupal to that level. So what do we do now? Well, you could decide to implement the Drupal container. That's one option. But because Drupal can get very complicated, our personal choice is to start as solitary as possible, meaning we cut Drupal as early as possible, and we might decide to make our test more sociable later on. But we start by cutting Drupal as early as possible. So these stack traces are very useful to accomplish that. So we can see here, this is our test. This is our class, feature article, and then it jumps to Drupal. So here's where Drupal is being poked. Content entity base in line 1055. So let's go check out what's happening over there. in line 1055. Okay, so we're trying to get field definitions. And so I imagine that this method is trying to use the Drupal container to get some service so that it can do its work. But what's important here is that this is being called in this magic get method. Now let me share the implementation of our code so you understand why this is happening. So our method is super simple. It's just using the field API to get a value from this field feature value. Because we're using this form of getting field value information, that is why the magic method is being called. So if we mock this method, we can probably cut the Drupal code from running early enough so that we don't actually need to mock the Drupal container. So let's try that. And I already have some code here that does exactly that. So let's replace this mock with the newly improved mock. So just to see what's happening here, I'm mocking the get method, the magic get method. And from the implementation, we know that when the magic get method is called, we expect an object with a value to be returned. And that's exactly what we're doing here. We're returning an object that has a value in it, and the value is false. That's going to make our test pass because we're asserting false. We're asserting that this node, this article node, is not feature. So let's run our test again. And now we're to green. Okay, so where you Drupal run, and as Eric mentioned, the balance, how much you're getting from your versus how difficult, right, or how to run. The final implementation, though I think we're already. So thank those of you that are sticking around. The code. All right. The full implementation looks like this. I don't want to go anything, but I wanted somebody look like when a return a service needs to return. It looks like this. So we have the entity type is returned, which is also node storage is being mocked, that returns a query. So you can see how you can have chains of mocks that return one mock after the other. And one last thing that I want to show you is where all of this code is being called. So the place of integration with Drupal is obviously a hook. And here we're calling this Presave method, which contains all of our logic. Here's the Presave method. It's very simple. We check to see if the article is feature. If it is, then we get all the current feature articles, and then we defeature those articles. So finally, let's see if this actually works. So we did TDD all up to the point in which we have our hook, and now we can do some integration testing manually just to see if TDD got us to the right place. So here is my instance of Drupal. I'm going to add an article node. And I'm going to feature it. I'm going to save it. So here we can see that the article is featured. Now I'm going to create a second article and make that one feature. It's now the feature article. And if we go to this article 1, this one is no longer featured. Who's our working? And we ran super fast through that. hopping will not kick us out. So thank you so much for sticking around. And if you have any questions, we'll stick around with you for as long as you're willing to stay here. And we will try to answer some of your questions, and maybe we can look at some things in more detail, since we, because of the technical difficulties, we had to go through it super fast. So at this point, we will try to answer any questions that anybody has. And if you asked the question previously, please ask it again, since we weren't really monitoring things that closely.
Yeah, thanks everyone. If it might make sense for us to do a birds of a feather on this topic, I'd love to connect with other folks that are doing the same work and thinking about testing. It's definitely a fun topic. I saw some questions about like when to use kernel tests as opposed to unit tests. And I think when you're testing functionality that crosses modules, that the kernel test makes sense. We're kind of focused more on just using the unit test base class, because all of our classes today in this demo were from a single module. And if you're doing TDD, it's really best to sort of focus on one system under test at a time, like we were talking about. So that we tend to gravitate towards using unit test case in most of our tests, but there's probably some things we could imagine in Drupal that kernel tests would be really good for.
And yeah, so on DCAN, which is probably the biggest kind of system that I've been working on at the moment, we have 0 kernel tests. All our tests are either unit tests illustrated here, or tests with something like Cypress. But we're starting to play around with Drupal test traits. Test traits are interesting because behave in a similar way kernel tests, but they give you just websites, and it has all your settings, your content types already pre-populated as you expect them to be. So I feel like that's a more useful kind of like PHP unit test, but is more linear or fully sociable thing. And I'm really enjoying the test because it gives me so mock the database. I don't want any to be still database. And the rest of Drupal is actually running. So this is there to be. You can go mocking everything and only running your, like most demonstrated here, or you can go as full Drupal and then like given the kernel mock fake responses, testing what the things that can do unit more like an integration. They can be also for TDD because they're fast and you know exactly what patient is working or not.
I saw a question about testing external APIs. That actually came up yesterday in the discussion of Drupal test traits, and I believe there were some recommendations of using the hat for that. I'm not sure if Cypress can test external APIs.
Well, if you're calling the external API from within your code, the way that I like to do it is, instead of calling the API directly, you just wrap that API call on your own class. So you have a simple class with one method, let's say call service XYZ. And just by creating that wrapper, it immediately gives you an entry point for you to mock that external service, so that your tests can fake what that service might give you as a response, and then your code runs as expected. Let's see what other questions. How do you test a method on a service with a unit test? So I will there are different philosophical stances on what a unit is, and I have worked with people that think that a method is the unit of work in systems, and so they try to mock methods. Uh, I, I don't like that philosophy so much. I think that in object-oriented programming, your units are your objects, and so you really don't want to test individual methods. You want to test the full interface of your object. And then the internals of the object, whatever the object does in its private methods and everything else, you try not to worry about. You just mock the public methods if you need to do that. Any other questions that we missed? Or any other questions that people still have? I have a custom service and it has a method. A custom service and it has a method on it. So if it's a custom service, I will almost say if this custom service is yours, you probably don't want to mock it unless it's very, very complicated. So you want to test it. Oh, well, in that case, it's just like what we were doing. So you instantiate your service class. You could do that by just instantiating the class itself and creating an object from this, or you can actually do it through the container. I've in most of my tests, I do have a mock or a real implementation of the container. Exactly, something like that. And then I expect the container to give me the instance of my actual class. And then from there, you're effectively testing your service configuration in a sense from the container, and you're also starting to test your actual class. No, so you're correct. But it really depends. So you have full control on how much bootstrapping you want to do. So this is my configuration file for the test that I ran today. Well, I'm not sharing my screen. Let me share my screen briefly. So this is our configuration for our tests, and really the important part is here this bootstrap piece of configuration. And I'm bootstrapping with the course bootstrap file, and this file only sets up the autoloader. So there is no container, there is nothing else. It's just the autoloader so that you can call any class that Drupal makes available. But you don't have to use that. So Jack, you were at the Drupal test rates presentation yesterday, and Moshe mentioned that he has a different bootstrap that comes with the Drupal test rates called Bootstrap Fast, and that one actually does bring in the kernel. So I think if you run the Drupal test rates bootstrap, you will have a fully implemented container. And then you can call the service and you will get your class, and then you can test it from there. So the range of possibilities are, it can be, Drupal can be as involved in your tests or as you want them to be, or you can minimize it by just like even mocking the Drupal container if you wanted to completely. Yes, I have unit tested plugins in the past, and it is the same philosophy. Like you can choose to go the route of just calling the service with you can get the container and call the service, and then some things might fail, right? Because the container is not fully set up if you're using my Bootstrap methodology. But then you can mock all of the things that the container will expect. Or you can go the Drupal test traits route and actually have your full container. You call your service. It will give you an instance of your plugin, assuming that you're managing your plugin through the dependency injection container. That's one important point is for unit testing, the dependency injection container is your best friend. You can, because almost, I wouldn't say 100% of Drupal can be accessible through the dependency injection container, but I would feel pretty comfortable saying probably 90% of Drupal is accessible through the dependency injection container. And so that gives you full power to be able to mock as many services as you want, or call as many real services as you want in your PHP unit test, depending on how much bootstrapping you're allowing PHP unit to do. No problem. Glad that you had some interesting questions for us.
Yeah.
The whole point is that you want, so here's a question from Dan, but the whole point is that you want to isolate what you're testing as much as possible. Otherwise, it's an integration test. Right. You're right, but so one of the takeaways that we wanted to that give you from this presentation is that really the differentiation between unit and integration is not as important as how fast your tests are. So if you can have you could have an end-to-end test, for example, and if those tests are fast and they're easy to write, and you can write them first before you implement anything, I think those will be okay for TDD. So we just wanted to show the unit test approach because it's not as common to see as other forms of testing, and they are the fastest. But if your end-to-end tests are super fast, easy to write, and that will give you full information about what your system is doing, then go for it. I don't think so. Test-driven development does not tell you what kind of test you have to use, just that you have to write the test first, and that they should be fast enough so that you get that feedback quickly. If your tests are taking 10 minutes to run, then at that point, those are not good tests for TDD.
Right. And the other thing is that TDD is not concerned with code coverage in the same way a lot of testing might be. It's really about driving this process of, getting these tools in place to help you write your code and to help you refactor your code. And it's sort of a nice bonus that you get code coverage from that pretty much goes down to your single lines of code. But also another point I wanted to bring up was just that all the guys that really invented this stuff were the extreme programmers didn't really believe in isolating their units. They wanted to have all their tests be sociable, and by doing that, it kept them from creating a really complex system. It sort of act as a filter. If you have that mindset going in, that we're going to create all of our tests sociable, calling real implementations of everything, you can still isolate your system under test, but you're dependent on components. If they're small and lean enough, should be able to be brought in to your unit tests without making them really fast or making them really slow. Yeah.
And then I do agree with you. So, but I think we're mixing concerns. So there are the kinds of tests that you want to do for the purpose of TDD, and then yes, you want to have a full set of regression tests. Which I'm not saying TDD cannot get you to full regression tests, but because it's more concerned with just big general behaviors, you might not get to full regression tests. But if you want to get there, that is fine. You can have like fully isolated tests that just look at one specific piece of logic and everything else is mocked, and just for you to be able to deal with a specific use case that is I don't know, an exception or something, or a scenario that is very hard to get to through normal behaviors in the system, and that is okay. And you can definitely do that with I have not found any scenario in which I couldn't mock things enough to get to a point in which I could have like full regression tests for any sort of scenario that I had with my classes and my services.
I think we've come to the end of the questions.
Awesome.
Wow.
Thank you so much for sticking around, and I hope you, well, let's not keep people around anymore. We're already 5 minutes on top of whatever the next sessions are, but thank you so much for sticking around.
Bye, everybody.
And we'll see if we can set up a buff.
Awesome.
Thank you. Bye-bye.